Hey, how's it going? Hey, listen, on this video, I'm going to do 4 different discrepant events, and I will explain how each one works after I do the event. Um, I really want to do these differently for my class, and I'll probably do live demonstrations for my class. But for this particular case right here, I just want to go ahead and show you that I have these discrepant events. You required 2. I wanted to make sure that I did get that other one in that we were supposed to do. So I thought, you know what? I'm just going to go ahead and do 4. Okay, so Dr. Bradley, here it is. And I'm going to show you these 4 discrepant events. Okay, first things first, to go ahead and give my references right here. All of these come from the Awesome Science Experiments for Kids book that you had us buy for class. And I will say this is a very, very good book. I like it a lot of good experiments to do, a lot of easy experiments to do. And of course, I think for some of them, they made them for younger kids, and I can tweak them a little bit for older kids. But anyway, here are my discrepant events. This first one is a fire extinguisher. And I'm going to go ahead and move the camera down off of me onto the table so you can see what's going on here. And if you'll notice, I have a candle right here that is burning. And I am going to attempt to do something here. I'm going to attempt to pour some air on this candle and put it out. So let's see what happens here. And that did not work. I know why it didn't work too. It's because of what I had right here. Okay, we have some baking soda and vinegar, and this reaction is causing a release of carbon dioxide gas. And carbon dioxide gas is heavier than air, but it still doesn't seem to be working right. So I'm going to try this one more time, and if this doesn't work, if this does not work, I'm just going to restart the video. Okay, there is our carbon dioxide gas that is coming into the container here. Let's just see if we can pour it onto this candle right here. Okay, and there my candle went out. Well, wait a minute, Mr. Ramey, does that really work? Oh, yes, that really works. Watch this. Okay, here's an ordinary match. I can light my candle with it. And now I'm going to put it out by putting it in this jar, but not all the way down to where the liquid's at. Oh my goodness, did you see it go out right there? There it is. Okay, carbon dioxide puts out fire. And let's see if we can put this candle out again if I have enough in there. Okay, I don't think I have enough in there this time to, oh, well, let's try it again. Let's see, 1, 2, 3, 4, 5. And let's see if we can pour some of that out on there. Okay, and again, none of my liquid from this jar was actually poured into where the candle was at. Okay, discrepant event number 1. And again, with my students, I would build up the surprise, maybe not even let them know what I had in this jar. Just have some fun with it and say, ooh, it's magic. Well, anyway, that's one of the things I'm planning to do here. Okay, the next one, again, using a bowl. Oh, and by the way, talking about, you see the smoke going up in front of me here? Talking about practical applications. This is how a lot of fire extinguishers work, using carbon dioxide gas to actually dispel the oxygen out of the room, and then the fire doesn't have anything to burn with, nothing to do the oxidation, and therefore it burns itself out. All right, here's my next one. And for this one, I also have a practical application for, but I'm going to take some ordinary pepper. This is just a cereal bowl right here. And this is ordinary black pepper. I'm going to put some on here, and I don't know if you could see it on the camera there, but it is floating right across the top of the surface of the water. And there's one thing I forgot to get. I'll be right back. and that is some Dawn dish detergent. Let's see what happens to this pepper that's floating on top. We put just a little tiny drop on the top there. Oh, did you see that? Did you see all the pepper go off to the sides? It just went within a half a second. Yes, what is happening here? Well, there could be all kinds of explanations that I would ask my students for, but the reality is the pepper is actually floating on the surface of the water, not on top of the water, uh, but on literally on the surface because of something called surface tension. And a um, when you put something in there like a soap, it causes the water to release its surface tension. So now it's not dome shaped anymore, but it releases that tension and suddenly everything is pushed to the side. And so that's what's happening here with our pepper. Now, what is the practical application of this? Well, that's real simple. I'm going to take the camera. I'm going to turn it around a little bit. I'm going to show you something that I have right down here. See my lamp right there? There's my lamp, and there is a dish of soapy water. Let's see what happened here recently. Our dog got fleas, and so in order to make sure that there were no fleas in the house, I put a warm lamp beside the wall here with a container of water and a little bit of Dawn dish soap in it. And what it does is it takes the surface tension of the water, and specifically during the night when the fleas are jumping around, they're looking for a warm heat source. And they see that heat source right there, and they go towards the heat source, and they jump around, and then they fall into that water. Well, if the surface tension on that water, they could actually go across the top of it because it's so light. But in this case, because I've broken the surface tension, now they sink down into the water, they cannot swim, and eventually they drown. So there's another practical application of the use of surface tension or the lack of surface tension in water. And let's see, there's an overhead shot. All right. Okay, so next demonstration here. Let me get it set up. All righty. Next demonstration's pretty simple. I'm going to use something that a lot of us see every day, an ordinary ketchup packet. Okay, and this ketchup packet I have put in a bottle of water. And so let's see if you can see here. I'm going to turn it where it can be seen real easily. There it is. And there's one thing that's going to happen. Suddenly, it's going to go to the bottom. Now, what is it that's causing it to go to the bottom? Oh, there it is going back up again. This thing must be alive. It's trying to survive. And then now it's going to the bottom again. What is it? Well, if you were watching my hand real closely, you could figure it out. And that is I was squeezing on the bottle. And in fact, I was giving it more air pressure. You see, when the manufacturer makes this packet of ketchup, there's little tiny air bubbles, the air pockets that are in this packet. And so normally that would cause it to float, okay? But when you squeeze the bottle and give it more pressure, it compresses those air pockets into a smaller space, thereby making it denser, which causes it to sink. Now, without going any further into this, I would really like to know, and I think the practical application is deep sea divers. Divers that go down in, say, 40, 50 feet of water, not so much a big deal. They can take their buoyancy compensator vest and fill it up with a little bit of air, and it'll take them right to the surface. But what happens when you're at the bottom of the, I don't know, the Mariana Trench or bottom of one of those really deep places like 1,200 feet down, and the pressure is so great down there? Do you float up or does it actually push you down? Now, obviously, they have to have special suits that they wear to do this, but that would be something for us to find out. And I have a suspicion that I have heard this before, that sometimes you get down so deep that you are compressed so much that you cannot float anymore, and you actually have to have motors or a cable or something to pull you to the top of the surface of the water. So anyway, there's event number 3, a little bit of pressure on a ketchup packet. I like to put pressure on ketchup packets too when I'm eating my French fries, because I have to tell you, you don't have French fries without ketchup. I mean, they just go together. That's like Batman and Robin. Okay, last discrepant event. Okay, you probably noticed a little glitch in the picture right there. Some things changed just a little bit, and that's because I needed to, I'd forgotten about my fourth discrepant event right here. And this is, of course, the baggy one who, what I've noticed about these bags, I love Ziploc bags. They're great. But it seems like every time I pull one out of the freezer and then melt something in it, there's always a leak. But yet, at the same time, whenever you have those leaks, you can take a pencil and you can push it right through this bag and it doesn't leak. Now, why in the world would that be? Okay, let's try another one here. There it is, not leaking. I took a pencil, 2 pencils, and put through this bag. It doesn't leak. Yet when I pull it out of the freezer, it always seems to leak. Well, I think there's a good explanation for this, and that is what I did is these bags are full of polymers. Okay, that's very long molecules that are made of different things, and they stretch very well. So when I poked this bag, I didn't actually break those molecules. I just stretched them around the pencils, and it created a seal. Now to answer my question, why in the world does it always seem to leak when you pull it out of the freezer and melt something? I'm guessing that when you have something in the freezer and you have something frozen and then it gets tossed around in there, you're looking for something, so you move it from here to there or whatever, it gets scraped against some other hard surface. And that plastic at that point is a little bit more brittle and it gets broken. And so then when you go to thaw something out, you can't really see the puncture in the bag, but there's a little tiny puncture and it leaks. But which is I imagine what would happen is if I froze this bag, stuck it, and then pulled it out of the freezer and thawed it out, I would probably have some leaks. And eventually, I could probably hit it with enough leaks that pencils that it would start leaking. But anyway, there's my 4 discrepant events. Um, I hope that you enjoyed this. Again, I do want to do these a little bit better on the videos. I would love to do something like with the floating head that I did earlier. I think that would be awesome to do with the videos. But the reality is right now, I needed to get this finished up for class. And a lot of these demonstrations I will do for my students in class, just as a live demonstration. So thank you very much, and we'll talk to you later.